Okay, so let's go through these first two practice problems. So for number 1, it says to solve for x and then write a justification for each step. So we're going to set this up just like we did with those algebraic proofs, where I'm going to have statements and then reasons. It might be a little bit cramped here. So when we're going through this, we're going to be really using the stuff that we learned in chapter 1 with like the angle addition postulate, segment addition postulate, definition of midpoint, everything like that. And so we'll go through those same steps on the left-hand side, but now all that we're adding is we're giving a reason for why we can do that. And so anytime we're doing a proof, we always want to start with what's given to us. And so I see I have a picture here where I'm solving for x, and there's several pieces of information that I'm given here. First, I'm given that the measure of angle ABD is 3x plus 5 degrees. So I want to write that in as something that I'm given. I'm given that the measure of angle ABD is equal to 3x plus 5 degrees. I'm also given that the measure of angle DBC is 6x minus 16 degrees. And I'm also given that the measure of angle ABC is equal to 8x degrees. And so the reason that I can state all of these is that all three of these are given. So just like when we're doing algebraic proofs, my first reason was given because I'm given that equation. That's going to be the same thing here. I'm given all of this information in this diagram right here. Now, if you recall with the angle addition postulate, I can add up these two angles and set it equal to what the whole angle is. And so to start off, I can say that measure of angle ABD plus measure of angle DBC is equal to the measure of angle ABC. So the two smaller angles add up to equal the whole angle. Now what's my reason for that? Well, my angle addition postulate tells me that that is the case. And I'm just going to put post to be short for postulate. Well, I'm wanting to solve for x, so now I can go ahead and actually substitute in my values for those. Well, I know that measure of angle ABD is 3x plus 5, so I'm going to put 3x plus 5 in for angle ABD. DBC is 6x minus 16. And then ABC is 8x. Now I need to write a justification for why I could do that. Well, I know that I can switch out those values since the measure of angle ABD is 3x plus 5 and so on. So my reason for that is substitution. Whenever I'm substituting in values, my reason is substitution. Now this is going to look just like our algebraic proofs because from here all I'm doing is solving. So my first step here is I'm going to go ahead and combine like terms. So 3x plus 6x, I get 9x. 5 minus 16, I get minus 9, or minus 11. What was my reason? Well, I combined like terms. Okay, and next I'm going to subtract 9x from both sides. And I get negative x. So my reason for subtracting, that is my subtraction POE. And then this step, all I did was simplify. Now to get x by itself, I need to divide by -1 to get rid of that negative. So since I'm dividing, that's my division POE. So I get 11 is equal to x, which I just simplified. And then I always want x to be on the left-hand side, so I want to switch this around to get x equals 11. And my reason for that is reflexive, which we learned about last time. So really all what was added from my algebraic proofs that we did last time is I have some different kind of given information. Here it was what those angle measures are equal to. And then I also had this first step here in blue where I had to say that the two angles add up to equal the whole angle by the angle addition postulate, and then using substitution. But from there, it's just like our algebraic proofs. Okay, let's try another one. So my statements and reasons. So first I want to start with my given information. So you always know that your first reason is given. You can even write that in very first hand. So now I need to see what I'm given. And so I'm looking at my diagram here, and I have 3 different pieces of information. First, I know that AB is equal to 3x. I know that BC is equal to 2x plus 3. And I'm also given that AC is equal to 6x minus 2. So all 3 of those are my given information. Now we need to actually solve for x. And so we learned in our first unit that the 2 parts here, AB plus BC, is going to equal the whole. So I'm going to first write that. So AB plus BC is equal to AC. You need this first step here. You can't just skip to 3x plus 2x plus 3 equals 6x minus 2, because that is not following the proof. The proof, you need every little step to show why you can get there. And so now I need to think, okay, why was I able to say that? So we need to think back to what that postulate was, and that was the segment addition postulate. That's going to be really similar to what we did before. So now I need to substitute in my value. So AB is 3x, BC is 2x plus 3, and then AC is 6x minus 2. And again, I can do that by substitution. I'm just substituting in what those values are equal to. Okay, go ahead and pause the video. I want you to complete this proof. When you think you have it, go ahead and press play. So the final answer you should have gotten here was x equals 5. So I first combined like terms to get 5x plus 3 equals 6x minus 2. And then I went so on. And again, we want x to be on the left-hand side, so I had to use the reflexive property at the end.